Algebra 2, Angles and Radian Measure. Okay, we have a few vocab to write down to begin with, so pause your video and write those down, and then I will explain them. An angle can be formed by fixing one ray, called its initial side, and rotating the other ray, called its terminal side, about the origin. An angle is in standard position when its vertex is at the origin and the initial side lies on the positive x-axis. I will do some examples of this, but all that it means is how to draw an angle. So we're going to have an x and a y-axis, and we're going to open up the angle to whatever degree it says to do. Next one, angle measures in degrees and radians. This is just showing you that we can talk about angle measures in both degrees, which you're familiar with, so like 45 degrees or 260 degrees, or we can talk about them in radians, which I'll explain a little bit more later. And the last definition is coterminal angles. A coterminal angle is just an angle that begins and ends in the same position. So whenever we draw them in standard form, like the first definition, they will end in the same spot. Okay, first thing we're going to talk about is converting between degrees and radians. So if I give you a degree, say 40 degrees, and I want you to convert it to radians, you're going to multiply it by this factor right here. So pi over 180. You don't need to put the word radians there. If I give you a radian and you want to change it to degrees, you're going to multiply it by 180 over pi. That's might be hard to remember which one to use, but I'll give you a trick in a minute. Okay, so we're going to start by drawing angles. So this is the first definition that we were talking about. And here's an example of an angle that's been drawn. So the angle started here, initial side. All the angles will always start right there. And then we opened it up to be about, I don't know, I'm going to say that looks to be about 150 degrees maybe. I'm just kind of guessing here. So let's start with problem A. You need to start by drawing your x and your y-axis. Your angle is going to start right here. So draw your first ray. A ray is I guess it would be a line that starts at a point and goes on forever. So that's why I put an arrow in the end. And then we're going to open it 240 degrees. So first of all, this first little bit here is 90 degrees. Plus another 90 is 180. And if you look back here at our picture, 270 and 180 is right there. We're going to open it somewhere between there. So 240, I'm going to say, is about right there. So this is what your angle should look like. It doesn't have to be perfect, but it should look something like that. All right, part B, same idea. Draw your x and your y-axis. Your angle starts here. And now we're going to go 500 degrees. So let's think about this. We go 90, 180, 270, 360. So we need to keep going. 360 plus 90 will give us 450. So now we're at 450. And we need to go to 500, so we only need to go about 50 more. So we're going to go just a little bit over halfway, and that's our angle. So that's a 500 degree angle. Our last one, we have a negative angle. So on all of my other examples, I started by going up, but this time we're actually going to go down. 50 degrees would be about right here. Remember, halfway between the two axes is 45, because that's half of 90, so I just tried to go a little bit further than that. So negative angles go down, positive angles go up. Okay, now we're going to talk about coterminal angles. So coterminal angles, again, whenever you draw them, they end in the same place. They're always 360 degrees away from each other. So we want to find a positive angle that's less than 360 that's coterminal with 395. So I'm just looking for an angle that's 360 degrees away. If I take 395 and I subtract 360, I get 35 degrees. So that's saying that 395 and 35, whenever you draw them, would end in the same place. So let me show you what I mean. Okay, here is 35 degrees, something like that. And then if we were to draw 395, it would start in the same spot, and then it would go like this. So they ended in the same spot. They're 360 degrees away. If I wanted a negative coterminal angle, which this problem doesn't ask for, but if it did on your test, wink, wink, you would just keep subtracting 360 until you got a negative answer. All right, and then B, we have negative 45. We want it to be a positive coterminal angle, so we need to start adding 360. And we get 315 degrees. That angle is coterminal with negative 45, and it's a positive angle less than 360 like we wanted. So that's my answer. Okay, now we're going to talk about radian measure. Another way to talk about angles is just the radian measure of your angle. So if you look at this picture up here, highlight it in yellow, the radius of the circle is however long. 1 radian is the same length for the arc. So it's just going to be another way to give examples of angles. An example of what a radian could look like would be like 3 pi over 2, or pi over 2, or 13 pi over 9. So that's how radians will look. If you went all the way around, it would be 2 pi. Circumference of a circle is 2 pi. That's where 2 pi comes from in that equation. So the two multiplication factors that you need to know again are pi over 180 and 180 over pi. So let's do some examples with this. Okay, this first one, I'm converting a degree to a radian. I know it's a degree because of the degree symbol right here. So what we're going to do is we're going to put it over 1. We always need a fraction here. And we're going to multiply it by one of our conversion factors. I want to move to radians. I want to cancel out degrees, so I'm going to put 180 degrees on the bottom and pi on the top. In the end, that helps me remember I'm canceling out degrees here, so that's why I want pi over 180. So what we're going to do in your calculator, I want you to put 135 divided by 180. And I want you to give me that answer as a fraction. So we get 3 over 4, and then the pi goes on top. I don't want you to put the pi in your calculator. I want you to just put it in the final answer. So that's the radian measure that is equal to, or equivalent to, 135 degrees. Okay, for problem B, same idea. I have a degree, so I'm going to multiply by pi over 180 degrees. Having a degree on the top and the bottom cancels out, and that means I'm going to be left with radians. So we're going to take negative 40, and we're going to divide it by 180. And again, I want your answer as a fraction, which is negative 2 over 9. And then the pi just goes on the top. Okay, problem E. I'm going to rewrite that bigger. I already have radians because it has a pi in it, and it doesn't have a degree symbol. So I know it's radians, so I'm going to multiply by, I want to get rid of the pi, so I'm going to put a pi on the bottom and 180 on the top. So, my pi's cancel out. I don't want you entering them in your calculator. Some calculators it works fine, some it doesn't, so just cancel them out. And now we have 5 times 180 over 4, or you can just do 5 over 4 times 180 in your calculator. Okay, so we get 225 degrees as our answer. All right, and the last one, we have negative 7.28. Now, you might be looking at this and unsure if it's a radian or a degree. The way you can think about it is if it doesn't have a degree symbol, then it's a radian. So this is a radian. We're going to put it over 1, and we're going to multiply it by 180 over pi. Now, in all the other examples, I told you not to put pi in your calculator, but here I can't cancel out pi because I don't have a pi on the top of my other fraction, so now we're going to actually put pi in our calculator. I don't want you to use 3.14. I want you to use your pi button in your calculator, so make sure that you find that button. And the answer we get is negative 417.11 degrees. It says 2 decimal places, so I rounded it to 2 decimal places. Okay, another way that we can convert between degrees and radians is by using what's called the unit circle. So right here you have a picture of a unit circle, and it just gives you common degrees and radians that you might want to convert between. So for problem A, 210 degrees, it looks like our answer would be 7 pi over 6. If you see right here, 210 matches up with 7 pi over 6. For problem B, negative 45, well, we see that positive 45 is right here, so negative 45 would be right here, so it would be 7 pi over 4. Oh, hold on. Nope, I take that back. Since positive 45 is right here, it would just be negative pi over 4. So we take whatever 45 was and we make it negative. And then if we find 3 pi over 2 on our circle, there it is, that matches up with the degree of 270. And if we find negative 3 pi over 4, we're looking for positive 3 pi over 4. And then we would just make that degree negative, so negative 135. I will not let you use this on the test, and usually you don't have nice angles like this to convert anyways, so I'm just showing you this so that you know it exists, but I want to make sure that you know how to multiply by either pi over 180 or 180 over pi, depending on what you're converting to. Okay, our last example is finding arc length. So we have a picture of a softball field here, and it forms a sector with dimensions shown. Find the length of the outfield fence. So this fence right here. We want to find this arc length. Our formula is S equals R theta. R stands for radius, and theta stands for your degree or your angle measure in radians. It has to be in radians. So if you're given an angle measure in degrees, you have to convert it to radians. So I see that my radius here is 200, and the degree they give me is 90 degrees. So we got to convert that. So let's take 90 degrees over 1, multiply by, I want to cancel out the degrees, so I'm going to put 180 degrees on the bottom and pi on the top. 90 divided by 180 is just 1/2, so we get 1 pi over 2, or just pi over 2. Okay, so let's use our formula. S equals, our radius is 200 times pi over 2. Again, don't put the pi in your calculator. It's going to give you a decimal, which I want you to have your first answer in terms of pi. So just do 200 divided by 2, so we get 100 pi. Then it asks us to also express our answers in decimal places. So now you can put it in your calculator, put 100 pi, and we get the answer of 314.16 feet. I guess I should have put feet on this other one as well.